Good morning, students. Welcome to the class. Dear students, in previous session, we just discussed that how can we calculate distance between incenter and the circumcenter. In today's session, we are just going to discuss about the similarity and the congruency of the triangles. In many questions, in many examinations, the questions from this section have been asked, and this portion is quite easy, but you have to stay focused. Okay. So firstly, we will just discuss what is similarity and what is congruency. Understand that? So we need to know the exact things about this. So firstly, we will discuss the difference between similarity and the congruency. What is similarity and what is congruency? We have to discuss at first. Okay. So congruency, what is the congruency? I'm just going to make you understand with the help of the example. Suppose here are the two circles. This is circle 1 and this is circle 2. And I'm saying radius of the first circle is 5 centimeter and radius of another circle is also 5 centimeter. So you can see these are two circles, both are circular, and the radius of each circle is equal. So both circles are just gonna to overlap each other. Okay. So when the shape and size, both things are equal, shape and size, both things are equal, they are known as congruent. Understand that? So in congruency, shape and size both must be same. Shape and size both must be same. So this is quite essential for the congruency. If we are just talking about the similarity, what is similarity? In similarity, the shape and size both must not be same. It is not necessary to be the same for both of the things. Understand? Suppose here is the circle and I'm saying that the radius of this circle is 7 centimeter. And here's another circle, radius of this circle is 3 centimeter. So which thing is quite same in both the diagrams? We can say shape is same because both are the circular, but size is not same. This one is the larger and this one is the smaller. So in similarity, shape must be same. Shape must be same. Shape must be same. Size doesn't matter. Size doesn't matter. Understand that? Now, you can say in congruency it is written that shape and size both must be same. But in similarity it is written that shape must be same, size doesn't matter. So we can say that each pair of the congruent will be the pair of similars. Understand? But it is not quite certain that each pair of similar will be the pair of congruent. Understand that? So you have to keep this thing in your mind that each pair of congruents will be a pair of similars. Each pair of congruents will be a pair of similars. It means all the rules related to congruency are just going to apply on the similarity, but each condition which is applicable on similarity is not going to apply on congruency. I'm repeating again, each rule related to congruency is going to apply on similarity, but each rule related to similarity is not going to apply on congruency. So firstly, we will discuss the conditions of the congruency, and then we will discuss the conditions of the similarity. So firstly, we are just going to discuss the things about congruency. So suppose there are different two triangles, and we just want to see that these triangles are congruent or not. So we have three different conditions. Understand? First condition is side, side, side. If all three sides of the first triangle are equal to the three sides of the second triangle, okay, respectively. Understand that? Then we can say both the triangles will be congruent. Second condition is that if all three sides are not equal, suppose two sides are equal and one angle between those sides is equal, those will be congruent. Second condition is SAS, side angle side. Okay, I am saying that two sides and one angle. And third condition is that angle side angle. two angles and one side. Understand that? So these are the three basic conditions of the congruency. But these three conditions are automatically applicable on similarity also, because we have understood that that congruent pair will be the pair of similars. So you have to keep this thing in your mind. Understand that? But now we will discuss the condition which is applicable only for similarity. Understand that? So here is only one condition which is applicable on only on similarity, and that is angle, 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 angle. Suppose here are two triangles, and all three angles of the first triangle are just equal to all three angles of the second triangle. Then these triangles are known as similar only. These two triangles cannot be congruent. Understand? So we can say there are four conditions which are applicable on similarity. But here are three conditions which are applicable on congruency. Understand that? Most of the questions which have been asked in SSC or CDS examination, they are based on similarity, because similarity is just covering up the congruency completely. Okay, getting me? So now I'm going to make you understand the results which are derivated from the similarity applying these conditions. Okay, suppose here are two triangles, and the name of the first triangle is ABC. Okay, this is triangle ABC, and I'm saying this is triangle PQR. Okay, this is triangle PQR, and I'm saying that angle A of triangle ABC, angle A of triangle ABC is equal to angle R of triangle PQR. Now I'm saying that angle B of triangle ABC is equal to angle P of triangle PQR, and the third angle C is equal to angle Q. Okay, so I have mentioned over here that angle A is equal to angle R, angle B is equal to angle P, and angle C is equal to angle Q. So we can clearly see over here that first all three angles of the first triangle are just equal to all three angles of the second triangle. So in that condition, we can say both the triangles are the similar. Understand that? So when we are representing the similar triangles, how we have to represent these triangles? So this is triangle ABC, and this is the symbol of the similarity. Okay, this is the symbol of similarity. Now we have written here triangle ABC. Now how we have to represent the another triangle? We have to represent the another triangle in form of the corresponding angles. How to identify the corresponding angles? When we write down the triangle ABC, which angle is written at first? So angle A is written over here. Now at first place we have written angle A here. We have to see which angle is just equal to A in triangle PQR. So we can see that angle R is equal to angle A. So at first place we have to mark angle R. In the middle place, at the middle place we have represented angle B. So angle B is equal to angle P. So angle P will be at middle place. Now this is C. C is equal to angle Q. So at last we have to represent angle Q. So we can say that triangle ABC similar to triangle RPQ. Triangle ABC similar to triangle RPQ. So this is very quite simple kind of method which we can use to represent the similar triangles. Understand that? So always remember, the similar triangles will be represented keeping the corresponding angles in the mind or keeping the corresponding sides in the mind. Understand that? Many times question have been asked from this same portion. Okay, examiner can ask the question like, suppose he's gonna to tell you angle A equal to angle R, angle B equal to angle P, angle C equal to angle Q. Then he is going to ask you the question like, which one of the following option is the correct? So he will give you the four option like triangle ABC, similar triangle PQR. Okay, so this is not correct. Why not correct? Because here the triangle PQR is not represented here, keeping the corresponding angles in the mind. Understand that? So in the same way, four options will be provided, but this option will be the right one. Okay, understand that? Now we are going to discuss the results based on the similarity. There are two simple kind of results which are based on the similarity, and we can use these results just to simplify our question. Result first says that, suppose here are the two triangles. Name of that first triangle is ABC. Name of first triangle is ABC, and I'm saying that the name of the second triangle is triangle PQR. This is triangle PQR, and I know very well that triangle angle A of this triangle is angle R of another triangle. Angle B equal to angle P, and angle C equal to angle Q. I'm writing over here angle A equal to angle R, angle B equal to angle P, and angle C equal to angle Q. So it is clear that both triangles are similar. I'm writing over here triangle ABC similar triangle RPQ. So first rule says that if two triangles are similar, then ratio of their corresponding sides will be equal. Ratio of their corresponding sides will be equal. So how to identify the corresponding sides? Firstly, here at first place I have written triangle ABC. So I'm going to use any of the sides of triangle ABC. So suppose I'm taking side AB. So side AB. Now we have to identify the corresponding sides of AB from the another triangle. Understand? Tell me which angle is just opposite to side AB. I can see clearly that angle C is opposite to side AB. Now I will identify that which angle is equal to C in another triangle. Angle Q is equal to angle C. Now just see clearly which side is just opposite to angle Q. It is side PR. So I can say AB upon PR. AB upon PR will be equal to. Now another angle of the triangle ABC we are just gonna to see here angle A. Okay, I'm gonna to write any side of this. Suppose I'm writing side BC of ABC. Now see BC is opposite to angle A, and angle A is equal to angle R. So side opposite to R will be corresponding to BC. So it is PQ. It is PQ. In the same way, now AC is remaining. AC is opposite to which angle? B, and B is equal to P. So opposite to angle P is QR. So these are the ratios of the corresponding sides. So always remember, if two triangles are similar, the ratio of the corresponding sides of both the triangles will be equal. Understand that? Now we have to add more information with this rule. Always remember, ratio of the corresponding sides of the similar triangles will be equal, and this ratio, the ratio of the corresponding sides, will be equal to ratio of their circumradii. Okay, circumradii. You know what is the circumradii? Okay, and this ratio will be equal to their in radii. Okay, in radii. Suppose in radii of in radius of this first circle is R1, and in radius of second circle is R2. So these two things are going to be equal, and this ratio will be equal to their corresponding altitudes h1 upon h2. This ratio will be equal to their corresponding medians m1 upon m2. This ratio will be equal to their perimeters, semi-perimeters. You can say s1 upon s2. And one more thing, this ratio is going to be equal their x radii. Okay, so x radii of first circle, and but all the things should be corresponding. Understand that? You have to keep these things in your mind. Okay, and you know very well how to identify the corresponding things. Okay, suppose I'm saying that the ratio of the corresponding altitudes. Suppose you are just dropping an altitude from vertex A. Okay, this is h1. Suppose now how will you drop the corresponding altitude of this? So identify the angle equal to A. Angle R is equal to A. So if you are dropping an altitude from vertex R, so it will be corresponding. Understand that? In that way, you can identify corresponding medians, corresponding altitudes of the triangle. Getting me? So this is the first rule. Using this rule, you can say that ratio of corresponding sides of the similar triangle will be equal to the corresponding in radius, to the corresponding circumradii, to the corresponding altitudes, to the corresponding semi-perimeters, to the corresponding x radii. Okay. Now, here is the second rule, which can be applied to simplify many of the questions. Here are the two triangles, both are the similar triangles. Understand that? And these two triangles having some area. Okay, so ratio of these two triangles will be ratio of the areas of two triangles. Triangle ABC, ratio area of triangle RPQ will be equal to the square of corresponding sides. will be equal to the square of the ratio of corresponding altitudes, will be equal to the ratio of corresponding medians, will be equal to the square of corresponding semi-perimeters. Understand that? I mean to say, ratio of the areas of the similar triangles will be equal to the ratio of square of all these things which have been written in the first rule. I mean to say, it will be equal to AB upon PR whole square will be equal to BC upon PQ whole square will be equal to AC upon QR whole square equal to R1 upon R2 whole square equal to small r1 upon r2 whole square equal to h1 upon h2 whole square equal to, understand, m1 plus m1 upon m2 whole square equal to s1 upon s2 whole square equal to, and so on. Understand? So these are only two rules related to the similarity. Okay, now we have understood the basics of the similarity, that what is similarity, what is congruency, and these are the basic two rules related to the similarity. Okay, now in the next session we will discuss the rules of the Thales theorem and midpoint theorem. After that, I can say that the maximum number of rules of the geometry which are applicable on triangle have been completed. Now we will do the previous year questions after that. Okay, so thank you so much, and I will see you in the next video. Okay, thank you.